Hi everyone. Hi Ari. Hi Sainath. So you can do that well. Like till D1 you have done in 1 hour 15. I think if you have done till D1 in 1 hour 15, you probably got scared of D2. So you have to eliminate that scared. That's getting scared thing for D2 and E2 and for every question. Okay. Sainath, do you hear me? So won't you kiss me on the mouth and love me like a sailor? When you get it is, you tell me what's my. So guys, like the video. Hitachi, even you should have tried more optimistically, okay? I'll share my screen. I'll show someone. I was telling the same thing to some other guy also that has asked me about my this one. Sorry, I was trying to say how I could have done it on la- Div1 plus Div2 B. Like, but I won't reply you guys if you guys message me, okay? So I haven't solved the problem yet. I haven't seen the contest yet. I want to do quickly. I want to do some questions quickly and then I want to leave. Okay. Because I have to sleep. And from next stream, I won't do much of streams because I'm busy. I think I have a lot of work from next week onwards. I'll be more busy. That's why I want to do on stream. And while I can. So here we are. Guys, do we have viewers? 13 viewers. We need likes too. How much years are you practicing DSA? Please tell. Are you asking about me, Sharan Ishwar? I don't think how many years I have practicing matters to you, right? Because you need not be as good as me, even though I can solve only three problems. In no way you can. You need not. In no way you can be as good as me. Why is it current standings? We cannot submit now, right? We cannot submit now. So what should I do? Or there's some other contest somewhere. So let's start with some difficult one. See, people who have solved D1, if they're not solving D2, they're unnecessarily not solving it. Let me read E, and then I'll come back to D1, D2, and then C. Okay, let's once read E, guys, because if you guys are seeing my videos, you guys should be used to reading difficult problems. D1 and D2 are both same things, right? I cannot start with D2, okay? D1 and D2 are same things. So that's why I'm going for E. So if you are seeing my videos, you guys should be able to read the problems, okay? You guys should be able to read difficult problems, give them the best try you can give, okay? Because there's no reason for to not try, right? There's no reason to get scared of a problem, right? Just give your best try. See, otherwise PCDs are useless. pcds are not to PCDs are not to learn solutions, okay? PCDs are to push yourself a bit better, okay? My PCDs are, yeah, like video guys, and my PCDs are to push yourself, okay? You have to, while I am here, you have to read the problems that you get scared of in general, because now I can guide you, right? Now I can guide you. So take pen and paper and then try to read this problem well. We'll try to solve this problem. It has less solves, but then we'll try, okay? So guys, read the problem. First step is read the problem. Everyone, like the video too. We define the weight of an array B. Let's try to work on that for some time. Consisting of m non-negative integers as, so we are defining weight as the number of indices I such that bi is greater than max of I. So first thing, see, unlike lead code problems, today I have seen a lead code problem. I have done a lead code problem today, but then they didn't even explain what a permutation is. They didn't even explain what a permutation is. See that lead code problems are more difficult. If you see Codeforces problem, they explain you what is a minimum excluded element is very clearly. See, they are explaining you what a minimum excluded element. It's like you have these puzzle elements. You have one puzzle piece called max. You have one puzzle piece called weight of an array B. The definition of that, it's one puzzle piece, and then you have some other puzzle piece like you're given an array. For any subarray, we denote the weight of this as that. For every I, You have to find the maximum weight over all subarrays A, ending at index I. In other words, so, and then we have an I. We have to find among all these subarrays, you have to find the maximum. This you have to find for all I. So now you have to think, okay, using this definition of weight, using this definition of max, and given that I have non-negative arrays, how can I find some algorithm? How can I find some process, or how can I solve the problem that if there exists a simple solution ending at here among all these things, you should be able to find the maximum weight quickly. You should be able to find some maximum weight quickly. How would you do that? You have to use logic. You have to use logic that the simple procedure you finally get, whatever the simple procedure you finally get, because if you see golden rules, proofs are simple. There is a simple solution, simple proof. So if that simple solution is true, maybe you will use some logic that for all else you can vary L, you fix I, but still you can figure out that okay, because of max definition, you can maybe still figure out that whatever the maximum weight, you can maybe figure out that. So we can work on the weight of an array. We can work on fixing I. You have to solve the problem, right? Maybe if you can solve it in O of n square, you have to work on that. And then maybe if you can simplify it somehow, maybe you can logically reduce it to simpler thing. You have to work on that, right? So it's not like it's a out of the reach problem is like quite common. It's you have to work, you have to gain some insights on whatever the puzzle piece you have, and then you fit them into a proof, a clear proof and clear solution that works out. Okay, AI is less than or equals to, and it seems because that doesn't matter. Max. So let's read what max is. Max is the minimum smallest non-negative integer that is not there in this minimum excluded element. Okay, minimum excluded. So do we have viewers? Guys, have you read the Hitachi finds it Hitachi finds it non he's not convinced that he has improved for my advisors. He's asking back, how did you improve? Did improved. Guys, 12 viewers is less. We need more viewers. Be active, guys. Have you guys read the problem? At a high level. At least at a high level. I will end the stream if viewers drops by 10. Okay. C seems difficult. So we are at E now, right? So we have to logically see what max is, and then we have to logically see. So what does weight is? Number of I satisfying bi greater than max of I, right? Bi greater than max of I. So how does that look? So it seems very simple. If you have this first, what's weight? Can you write it in a better way? It's nothing but bi greater than max, right? So count of this. Count of I such that bi greater than max. Right, because it's number of indices I satisfying bi greater than max of b. See, you guys should also learn this notation. These notations will help you see things clearly, a bit more mathematically. See how I represented that as a set of indices such that bi greater than max of b, and this signifies that number of elements. This is weight of b. Okay. Now we need, because if you imagine them as puzzle pieces, like we also have to define what max is, right? Okay, if b has 0, 1, 2 up to so on, it misses this value, and then you can have multiple 2s, you can have multiple 1s. Okay, but then the first value that is missing, the first value that is missing, after that you have these things, and you want number of these things. Okay, you can also write this as number of values with something less than that something less than that is not in the array, is not in the array. We can also write like that, right? So number of values such that there is something less than that. There is something less than that not present in the array. Maybe you can write that also. You can just modify the w of b into this also. It's nothing but because for all these things there is every non-negative integer less than that exists, right? Less than or equals to. You can rewrite that as like this way. Number of values such that something less than that does not exist. Okay, number of values such that something less than that does not exist. So now let's also see this as a definition, because that's a simpler thing to write it in terms of these values. For each value, if something less than that is not exist, it's a simpler. It's why is this a bit more simpler? Because it's focusing on one particular element, right? It's focusing on one particular element. Like instead of telling with respect to max particular value of max, now I'm telling it in terms of, okay, if there is something less than that non-existing in that, then that's good. But now we need to see, okay, in more often we can find this easily, right? More often we can find this easily. So in more of n2 we can probably find w of I comma I, w of I minus 1 comma I, w of up to so on 1 comma I. We can find all these things too in O of n, right? We can find all of them too in O of n, right? So in n square we can solve the problem. For for n square we can solve the problem, but we have to now logically think how to get, is there a relation between these things? Is there some L that will always be maximum? Maybe. Is there some L? What can you say? How can you say how can you see these things in a nicer way? So let's say we are at I. We have some value. And then as you keep adding values, okay, as you keep adding values, let's say max was here. Okay, let's say max was something. As long as you add something greater than max or less than max, it's fine. You can keep adding greater than maxes at all. Let's say g at all. But then what happens if you add max? Then the value reduces, right? Once you add something new that isn't there, no, once you add max, then the value reduces. Then why would the value reduces? Now some things will come into less than whole. So max will shift. So some things will shift. So as you keep going, it increases and then decreases. It increases and then decreases. But still, how can we find maximum? Maybe can we brute force on some particular max? Can we brute force on some particular max? We can think of all these problems, right? Can we brute force on some particular max? And then can we proceed to I? Maybe let's say we were able to brute force on particular max. Okay, because it's increasing and decreasing, let's try to brute force on max. Maybe we can brute force. Brute force in the sense, you need not do, you can brute force on O of n things, and then you can just add new element and then again find whatever the changes are. It's not that difficult, okay? I mean, what I mean is, it's not, what I mean by it's not that difficult is, you can maintain more than O of one things. You can maintain for all maxes, and then when a new thing comes, you can think, can I maintain again for all new maxes? You can think that too. But even before adding I plus 1, let's see if I fix max. If I fix max, okay, so I need not even fix max. I can just fix max less than or equals to x. Max less than or equals to val, let's say. Max less than or equals to val means something less than val is missing. Something less than or equals to val is missing, right? For this thing, probably something less than or equals to this is missing, right? So let's try to look at it in that way. Something less than or equals to that is missing, okay? So if you're at I, something less than or equals to this is missing, right? Would this value keep decreasing? Like, would this decrease as a binary search kind of thing? Not binary search. Would this value keep on decreasing? Like, what I mean is, When will this happen that something less than or equals to max missing? Initially, it happens for all the values, almost all the values, right? Something less than or equals to this missing. But then as you keep going, values keep filling up, filling up, filling up, and then max will keep increasing, right? As you keep going, max will keep increasing. It's nothing but max will keep increasing. Okay, let's try to see. Okay, if you fix max, what does that mean? Let's say this was the max value. Okay, you cannot go beyond this. You cannot go beyond this. Why? Then max will become that, right? So till here you want. I'm fixing max itself. Let's say let max equals to val. Suppose we are trying to cover all possible maxes. Suppose max was val. Then we want frequency of after val. We want frequency of elements. We want count of this set. Let this last val index be j. Then we want count of I such that g greater such that ai greater than val. That's what we need, right? We want this count. If I'm fixing val, that's nothing but the same thing. If I fix val, I want count of this thing such that I greater than j. What is j? The last occurrence of val, right? Because till here, if max is val, it cannot be till here. It must be till here only. And then it's hurting here something. If there are less than 10 viewers, I'll just drop. It's not E already. We are starting with E because you guys should try more, right? You guys should try more. You guys should not get scared of problems. That's the biggest step, okay? It's not about topics. If I can make you guys not scared of Div1 or D1 or D2 or E, then you guys will try B with more optimism. If you try with more optimism, you can guess better, okay? So it's all about getting exposure that, okay, these problems are not difficult. We can solve them. We can work on them in the worst case. So if I fix max, this is the least anyone can do, right? If I fix max, I want count of values greater than this. Okay, if I fix max, I want count of values greater than this, right? So you guys, this set is well defined for each val. Pos of val, let's call it pos of val. This set is well defined, right? This set is well defined. What I mean by well defined is when you're at I for val, you will count number of things greater than val. If this is being max, you can take till here, and then you will have number of things greater than that. If you have that count, do you guys agree that answer equals to max of pos of val for all val? Do you guys agree that for a particular I, do you guys agree this thing? Or let it be k greater than or equals to, sorry, I greater than or equals to. Do you guys agree this? Hello. So what do we doing? See, Pradeep, we are just fixing val to be max because we have many subarrays, right? Each subarray will have different maxes, right? So let's say max is being val or max is being less than or equals to val, means val must be missing probably, right? Let's say max is equals to val. For max to be val, if you're fixing max to be val, you can only consider this subarrays, right? You can only consider this subarrays. And for this subarrays, all the indices that are having greater than val will contribute to answer if the max is being this. Okay, if max is less than val, that's even better. That's even better. Okay, maybe while finding that max, we will do better. Okay, do you guys see that? This is simple, right? So anyone else? Eshmohota. I don't know how you're doing in contest. Can I Google you? That's great. But can I Google you? 51560. Nice, bro. Okay, I know your picture. This is not you though. Sorry for doing this. You should have responded me. You should have responded to me before. 1560 is nice, bro. You can become expert soon. Have you ever done? This is a big jump. All these are also big jumps. So you don't give often, but then you try to give them well, right? Damn, nice, bro. Damn, you're solving masters more experts recently, more purple colors too. Try more purple. Try more orange. Okay, try more purple and orange. So, Eshmota, did you understand the question? Like till here it's okay, right? Do you agree that answer is maximum of among all? We are brute forcing. This is nothing but brute forcing, right? Max being this, answer will be max being this answer will be greater than or equals to pos val. So we are able to find if we can maintain these things for all vals. If we can maintain these things for all vals, then we are good, right? Then we are good. If we can maintain these things for all vals, we are good. So let's say we are maintaining that. Is this clear till here? Guys, till here it's clear, right? I want someone else to say yes. Or Ari or Sainad, till here it's being clear, right? Respond, guys. I'll get water. Take some time, respond. Maybe see this one. Take some time to respond because you guys seem to be slow as snails. So guys, why are you people not responding? Can you guys not respond? Whoever is present. Hello. I don't even know if it's working or not. We got high. So focus on E now. Whatever I'm telling, focus on this. Is this clear till here? Tell me that. So what? We're trying to fix max val. Once you fix max val, what are all the possible subarrays you have from I backward? You cannot exit this, right? Then max cannot be that. If you exit this, max cannot be that. So until here, if max was this, you want number of values greater than max, right? Number of values within this range greater than val. If you have this one, okay, the thing is there could not have been some other element here, but still answer is greater than or equals to pos of val. Okay, answer is probably greater than or equals to pos of val. And then if you're covering all val, optimal will have some max, right? Optimal will have some max. If you're covering all possible vals, optimal will have some max. So that will be covered, and then you will have your maximum. Is this clear till here? Okay, Nirmit, but can you say if it is clear till here or not? This seems simple, right? Too simple. We have I, we have max, we have. I'm fixing max value, trying to brute force max value. Okay, guys, see this. This seems clear. We are brute forcing max value, and then among all subarrays, we have the subarrays. We have to be very careful that even if some other thing is missing, we will have even more score. So we are able to get at least this much score for all pos values. And if we look at if we when we touch the optimal max, when we touch the optimal max, that will perfectly work out. For optimal max, that will perfectly work out because there cannot be better. So now if you are trying to find all these things, okay, there is a meaning to J. J is last occurrence of val. Okay, let's say you have these things for I. You have these things for I. Can you get these things for I plus 1? Then you're done. If you can get these things for I plus 1, then you're done. You want maximum among everything. You want maximum among everything. If you can get these values after adding one new element, you're done. Okay. After adding new element, let the new element be val. Okay. So now you're adding new element val. Okay. See, J of only val will change, right? This is clear. Why? For other things, the loss occurrence has not changed. Val minus 1's loss occurrence has not changed. If something hasn't occurred at all, let's keep its loss occurrence as 0. Minus 1. Let's keep it 0 or minus 1, whatever the index you're using. So only this thing will change. Only for this, J will change, right? So J has changed it. And then what will become pos of val? Pos of val will become 0. And then what happens? What happens to pos of x such that x less than val? Would these things get affected? Would these things get affected? Why? What does this mean? You have x somewhere. You have x somewhere for, and then you have these things. Now additionally val came. I think all these things will get pos of x plus equals to 1, right? This is what happens to them. Why? Some other element came which is greater than val. Some other element came which is greater than val. So for all these things, they will just become plus 1. So now if you're trying to look at pos of x greater than val, would these things get affected? X is already greater than val. And then what is pos of x? We are trying to see values greater than our val. So we are trying to see values greater than x. A new element came, but it is not greater than x. So this doesn't change. This doesn't change. This doesn't change. So when you solve a problem, you have to come up with this logic. You have to think maybe max is brute forcing, because if you cannot get good something good, Probably it's brute forcing all possible values, right? Probably it's brute forcing all possible values. So we have defined how difficult is this brute force we are trying to see. If this is not working out, we have to go back and then we have to do something else. But then this seems to be working out, right? We have to change for val, we have to make it 0. For everything greater than val, we have to do plus plus. For everything less than val, sorry, for everything less than val, we have to do plus 1. For everything else, we have to do greater than, we need not change them. So it's like range plus 1, you will make one particular value 0 and then you want total maximum. Doesn't seem that complex, right? See, problems can just be solved like that if you guys do things well. Do you see that? Does this problem even has some logic? I don't think it even has some logic, right? It doesn't have any logic. It's a bad problem, I would say. See, it seems to be a bad, I mean, I don't even get some satisfaction of solving here. Direct. Is this correct? I'm doubting now because of how obvious this is. But it may be difficult because people will get scared of E, right? People, see, if someone has segmented template, they can do it in 5 minutes, maybe. You guys can do it in 10 minutes, maybe. If you guys can keep 10 minutes of work on a problem, maybe you'll notice that if you don't have fear, maybe you'll write these things. Maybe you'll see that, okay, if I brute force V, here itself you can think, if you don't brute force V, if you don't brute force max, what logic can help you that solve the problem in a simple way? It doesn't seem so, right? You cannot say that this I would be the best, this L would be the best thing. You cannot say that easily. So probably brute force works. So you have to think how to proceed further. You have to think, is brute force the answer? I mean, is there a simple proof here? Is there some logic that can help me here? If you are not seeing some great logic, maybe brute forcing seems to be a simple proof, right? Solution is this, but proof is simple. Why? We are covering all max. We are covering all possible max, and for a particular max, this is the optimal value. So when that max occurs here, when val equals to max, we are finding the perfect answer. So we have answers. Pos of val is a lower bound for answer, and then at some point, because you are brute forcing, you will find the answer too. So this is perfectly answer. Pos of val is a lower bound. Why? Maybe val minus 1 is also missing. Still pos of val is a lower bound. Then val minus 1 is a max, and then everything greater than val is a lower bound still. So answer is definitely greater than or equals to pos of vals. But then when val equals to the optimal max, answer equals to that. So covering this set is enough. And then you have to see how complexly these values are changing. If you try to see that when a new element comes, J doesn't change at all because lost occurrence remains same. Only this one will get changed. And then if you see, okay, now lost occurrence is not changing. If you take that value, a new element came. If that value is less than this new element, plus plus, else nothing. Same simple structure. You can maintain all pos values, you can go further. So why is this problem difficult? Because people get scared. People get scared of the problem. Max, I'm scared of max. I don't know what max is. Range, maybe it uses some topic. Maybe it's something complex. You guys have to agree. You guys have to believe that solutions are simple. And the fact that there is a simple solution tells you that maybe brute forcing works. Why? Otherwise, you cannot see a simple solution here, right? So now, maybe let's try using segment tree itself. I don't know segment tree much. Let's try using segment tree itself. Okay. Let's try using segment tree. Segment tree lazy. What does this give us? I don't even know if my templates are correct. We need maximum. We need total maximum, right? We need total maximum. So let's just keep it like minus infinity. We want total maximum, right? I think initially I can keep everything as 0. I need not worry about that much, but let it be. So initially, we can think of something else too, but then we have to do plus 1. We have to do plus 1, and then we have to do plus 1, and then we have to get maximum. We have to do plus 1, we have to get maximum. We have to change, we have to do range plus 1, prefix plus 1, we have to do, and then we should get maximum. That's why I'm using segment tree, because if it's not maximum, Fenwick tree would have worked. If it was some, Fenwick tree would have worked. But this problem is working because it's maximum. See, you cannot find sum of all the things, right? You cannot find sum of all the answers because using this logic it's not that easy. But maximum is easy. See, even that helps us that okay, it's maybe brute force on max. I have to check how do I look. I think it seems fine. Like the video, guys. I cannot shout much. So we have to update. We will do range update. What is a range update? Adding some value, right? Range update is adding some value. And then we want minimum. Okay. I will explain segmentary later. For now, don't care it. Don't care much about it. And then we are resizing it with, I think I can just resize it with 0. Initially, everything is 0. Okay. Because answer is greater than or equals to 0, right? So we have range update. We have initially everything being 0. We have a query. So now we can just solve the problem in an easy way. We want to maintain last index, right, for each value. Int, should I call it last index? J is last index, right, last occurrence. Int n, scene n, int a of n for I think we can solve the problem as we go. We need not even store an array. We need not even store an array, right? As the values keep coming, we can just solve the answer. So let's not even store an array. Segment tree S of n indices, but n plus 1 vals, right? What are the vals that matter? What are the values that matter? Values matter from 0 up to so on n. If you find these values from 0 to up to so on n, we are good. Right, let's just find it for 0 up to so on n. Okay. Make inputs. Initially everything is 0. Okay, we also maintain last index. This is our j. This is our j. In here, this was our j. Last idx of n plus 1 equals to, let's say, as 0. Okay, let's keep it as 0. See, we don't even need last index. We don't even need last index. Why? Because we are using last index logically to know that whenever val comes, this last index has become 0. This last index has moved here. So if you just change pos, we don't even need last index. We are using last index logically. We are using last index for our advantage, but we don't even need last index. So initially, let's assume everything's last index is -1 or something. Now a new element came. What happens when a new element comes? Seen well. So for x you should do plus plus. So how to do that? Range update of 0 comma val -1 comma 1. Maybe this is what it is, right? We have to do this. Okay. See, I'm not even using build. I'm not using build because I'm not taking a vector inside. I'm just taking n, only n. This is what I'm using. Okay. And then I will get pos current value. Okay. Pos val equals to s dot range query of val comma val. This will give me whatever the current value is in that position. Okay. Now I have to add to this position. I will add minus pos val because I want to make it 0, right? Initially now it is pos val. I'm adding minus pos val to make it 0. And now what is the answer? We can just output it directly. This seems to be bad. This cannot be correct. This cannot be correct for E, right? This cannot be correct. I don't want this to be correct. Paused. Is this a joke? Is this a joke, guys? And then you guys get scared of E. And then you guys get, I cannot do implementations. I get the solution. Let me mock you more if I get it accepted. I get the ideas because I have smart brain. I get the ideas, but then I cannot implement them. I'm trapped in this tricky situation where I keep getting ideas because I'm so smart, but then I cannot implement them. Only my implementation skills are lacking, even though I was a genius board. And then you guys make such comments, make your solution crystal clear. Then implementations are not hard. What the fuck is this? We are not even maintaining an array here. Right? We're not even maintaining an array here. Is this problem supposed to be solved in 2 minutes or 5 minutes? What is this, guys? That's what I thought, Arpitkas. I will do one video per week if I become busy because I'm trying to shift to some other company where it will become uh, more work. And I have to focus on that work too because that's good for my professional career, right? And after that, if I get Sunday free time, I will try to do one stream or so. But see this one, see this problem. I can't mock you guys to make you understand the points, okay? I don't even know why it is difficult. Why is this difficult? It doesn't give me any satisfaction except the fact that I'm not even maintaining an array. I'm just taking value, outputting directly. This is the only thing that gave me a little bit of satisfaction because less than val do plus plus, make it zero. Very only thing I liked is not even maintaining an array. That's the only thing I liked. See, segment tree is not about segment tree. Segment tree is not about segment tree. It's about it just lets you do few things well. But the idea was to brute force everything. Once you have the idea to brute force everything, now this is what you have to maintain to brute force everything. Can you get the next thing? If you want to get the next thing from this thing, what all you have to do, if you think about that logically, okay, I want to maintain these things. Now a new element came. How can I maintain them again? If you try to work on that logically, if you try to see that, then you will get this thing. It's not coming from random ideas, right? Idea was to just brute force that comes from simple proof. Okay, proofs are simple, solutions are simple. If there is a simple proof, maybe brute forcing seems to be a simple proof, right? Can that work? You have to think about that. Okay, if I maintain these things, it works. Brute forcing makes itself, and then it's done. See, so we have to share my videos to other people. So let's go and solve D1 and D2. Okay. So guys, now we have seen E. Don't get scared of D1 or D2 because see, why is he difficult? You guys can't even try because you guys get scared, right? Really, we get scared. See, what I try to say is, if you think of golden rules, only then you will think of brute forcing mechs. Otherwise, maybe you'll think there is some great logic in here that you use some mathematical property of mechs, whose definition is quite simple. You will use that property of mechs, and then you will somehow use some magical for all indices. This thing is mechs. You cannot get it out of anywhere. Right? Maybe you have to brute force something. Maybe if you cannot brute force mechs, maybe you'll brute force something else. So brute forcing seems to be the way here, right? Otherwise, I cannot imagine a proof, some great proof here that comes and helps us. And now, if brute forcing is the way, it's work now. It's not great idea. It's work. It's doing work. Okay, this is work. Writing this is work. And then seeing this is work. Can you get these things for I plus 1? After adding a new element, let's say new element be val. This is work. So do you guys see it's about doing work? So let me try D1. D1 and D2 are related, right? That's why I'll try both D1 and D2. So let me write D1. Bro, I was not able to solve, in my important contest, I was not able to solve B. So we cannot say. I don't know why I was not able to solve that. I don't know why I took time on this thing too. And then I don't know why I took time on this one too. I wrote this here itself. I wrote this here itself. I should have gone more and seen more this. After this, I just wrote this and then I left that. Because see, I was able to write this here itself. I should have paid more attention to that. X is even. This is the first step I was able to say. X is even. It's not about X greater than 1. And then I was telling some weird, unimportant, random guesses. I should have seen this well for D. Then it would have solved instantly. It would have solved in 2-3 minutes. If I have seen that properly. Problem solving is about seeing things, believing in golden rules too. Because I wrote golden rules 4 years back or so, not even now. My golden rules I wrote 4 years back. Let me read the problem. This is the easy version of the problem. The difference between is L equals to 0 and R less than. You can hack only if you solve both of the problems. Let me just check what is D2 do. 400 solves is an easy problem. I need not, this is not a good problem. It's an easy problem. But why am I telling it's nice is it's 5 lines code. Right? People can solve complex mathematical problems like G just because they are good at math, but they cannot solve this E. I don't get that. They are definitely cheaters. Like, I'm just joking. I don't even know how that guy is so dumb enough to put that post out there. I am smart. No, Codeforces problem gave a math problem. Math is equally difficult as Codeforces, right? This is also math, right? This is also math, right? Here, what we are doing, this is math, right? Math is not what you do in multiplications and additions or calculus, right? Math is more fundamental level, using definitions to get some results, to prove something is max, to prove some. If you cover math is math, okay? Don't say like you know math. Everything is math, okay? CP is math. You are given two integers L and R because you have to prove things clearly. CP, computer science is a field of math. No, maybe not. I don't know. Let L equals to R minus L plus 1. You're given two integers. We will create two arrays A and B both consisting of n integers. Initially, both A and B are equals to this. Both A and B are equals to. Okay. Range. Initially, both of them are this range. You have to reorder the array A arbitrarily to maximize the following value. So we have to reorder A to maximize this value. Initially, L is 0. What about the other L? So we keep getting many queries, right? We keep getting many queries. Here R is big. L also can be greater than 0. Here L is 0. R is this. So first you will solve this, and then after solving D1, you guys should not go, oh D2 I cannot solve. You guys should go, how can I use whatever I got in D1? How can I extend little bit the idea to get D2? That's how you have to think. Otherwise, they won't be D1 and D2. Okay? Don't see solves, don't see anything. Trust that if you have done D1, D2 will be one more point. You have to trust that thing, okay? You need not see solves. See, what we do is when we know D1 and D2 a bit not, you guys should give that more importance than or thinking you cannot solve some things like that, okay? A possible way to reorder array here. We also have to output that, but then here we cannot output that. We only have to output what the fuck? But how can we do this? Okay. This is fixed. The ranges can go anywhere, but then this is fixed, and we have to give importance to the fact that we can even find the array. Even in this problem, we can even find the array. Proof. You have to think, okay, if I can simply prove that whatever this range is, we can find the answer. That this is best. If I can simply prove that, what can I say? You guys can think such things too before quitting, okay? So let me think of this one. L is 0, R is small. And we have sum of R bounded. So we can do O of N. But still, D1 must help to solve D2. So we have to take some insights from D1 after solving D1. We have these R's. Can I always make something big? Is what we can think of. Can I always make it big? Can I always make it big? Is what we can think of once. Another thing I can think of is some small observation I can think of is if R equals to 1 1 1 1 1 or something. Okay, we have 0 0 0 0, right? So if R is this and 0 L is this, then we can always do bi equals to complement of ai. Sorry, ai equals to complement of ai bi and make everything as ones. So this is an upper bound because this is the max you can get. So when r equals to this is the max you can get. Okay. Once think of, are there any other ways to do this? Are there any other ways to do this? Probably no. I don't think there are any other ways to do this. Okay, I don't think there are any other ways to do this. So now think of this thing. You have L. It has some prefix matching, right? You have R. It has some prefix matching. The first time they differ, L would be 0, this would be 1. Okay. Now can you make everything seems a bit difficult? Keep this aside. Okay, if L equals to 0, then let's look at that value itself, right? Let's look at this value itself. So you have R. R has some bits. Okay. Let's look at this thing. Let's look at this thing. Everything less than this, we can use this logic itself to make the maximum possible, right? We can use that logic itself to make the maximum possible, right? But now you have few of these things. I think we want some of this to be maximum, right? I think we have to add these ones. We have to add these ones in a separate way. We have to add these ones in a separate way, right? So what can I do? What can I do? So I want these ones to be matched well. I want these ones to be matched properly. I don't want those ones to go waste, right? What I mean is this AI ones, and so number of ones, maximizing these ones is always beneficial, right? Those logical points you can say obviously. We should maximize first count of capital ones, maybe or not. We cannot say this. We cannot say this. Why? Just because you're maximizing these ones doesn't mean you may be losing so many of other things. Okay. So this is not that great. This is not that great. But whenever these things are smaller, when we are trying to pair it with the complements, right? Okay, one minute. Think of this thing. If you pair them with their complements, you're using every single one. You're using every single one that is possible. That's the optimal, right? That's the optimal. You cannot do better. You cannot do better than that. You're using every single bit. What happens with R? Two things may be lost, right? but then you're using every single bit. So that's definitely an upper bound. Is an upper bound in both or comma. You're using every single bit in B comma A arrays. So that's an upper bound. So can we use the same logic here? Can I use every single bit? Think of that. Can I use every single bit? So to use every single bit, so let's just pair this with the complements where one is existing. Okay. Let's just pair this thing with, okay, now we are left with one things, right? There is one and we have these things. We are left with those things. So to use every single one, whenever we use this complement, we use one here. Okay. So now what we are left with? So whenever there is one, you will use a complement and then you're done. So now what you are left with? You are left with values that are left, that are less. Remove that first one. You're left with these values on the top and the same values on the bottom. You're left with these values on the top and the same values on the bottom. Right? Because we are trying to use one as complement. So these things don't have complements. These things are left. So now how to pair these things in the best possible way is what we have to think of. Okay. Maybe I'm complexing this easy problem, but let's wait some time. Okay. So these are like almost optimal, right? We are trying to complement them. So you have first one here. You have first one here. Now you have to pair all of this with all of this. Can we follow same procedure to pair these things? See, it's the same problem, right? It's the same problem. We are able to use every bit. So again, if you believe that proofs are simple, you can try for upper bounds. What is an obvious upper bound? See, maximization means you are saying that it's always less than or equals to this. Means this is an upper bound. So this is the best upper bound. When you prove that this is maximum, that means that's an upper bound. So now if you think of the problem, it's like not random guessing. If there is a simple proof, maybe every single bit is getting used is an upper bound, is a good thing, right? Maybe every single bit getting used is a good thing, right? So we will continue the same process again. So now we have to pair this with this, right? So what would I do? I would go for this. I would go for 0 and then complement. Okay. But if you notice, both of these are zeros. If you notice, both of these are zeros, but then we ignore the first bit. From here, they are complement. From here, they are complement of each other. See? Whatever the first bit is, from there, you can make them complement of each other. So what is the statement now? So it's always, so if D1 is this, maybe D2 is also same. Maybe D2 is also same idea that you can always pair them in such a way that all ones will match to all zeros. So now you have what is D2 itself. Otherwise, this D1 will not help, right? The D1 idea was all ones will be useful. Maybe D2 is also, there is a way where all ones will be useful. Maybe. Right. So in other words, it's like from maximum you're coming and then you're trying to come and then you're complement, you're pairing it with their complement, right? For AI, for or BI, you're trying to pair it with their complement. And then when you come down, I don't know how to solve it. Take the max bit, pair all of these things, pair pair 2 power max bit minus 1 things. You will pair all these things. But then these things are left out. Just from 0 to these things are left out. So now you have to solve the problem for these things. Just for these smaller things, you have to solve the problem. So it is like you remove you if you arrange A in increasing order, you're leaving few small things. You're making these things complement. Now again you have to solve from here. When you have to solve from here, from this number, now that number again has 1. Okay, what will you do with that number again? You have to go to the next bit active. From there you have to solve again, and from here you can again make them complement with respect to this bit. From these bits you can just complement, and then you have to keep going. If I complex the problem, but this is the solution, right? Okay, so I think that guess has worked out to people, right? But then you have to prove that to a bit that they perfectly match each other, right? So I get it. I get it that I get the answer is simple. Instead of this thing, it's complements because the answer is now for the highest bit. I'm making the highest bit as all the bits where the leading bit is active. I'm making them as 1 1 1 1 1. So with that, now I try to simplify the implementation. I can see that for all the bits where there is 1, I'm making them all ones, and then I'm making that, and then XOR works. But then because you're guessing, you're coming from that direction, but I'm coming from this direction because I'm able to see that okay, if there is a simple proof, maybe we can always make them complement. First, I was able to come from here, and then I realized that complement is an upper bound. Complement is the best you can do, and then we can see if we are also able to make everything as that. Okay, now I'll just implement. Now I'll just output that. But now, how does this differ? How does this differ? How does L comma R differ? I don't think they differ, right? Because some prefix is same. Some prefix is same. Whatever you do, and then you have 1 here, and then you have 0 here. Okay, but then you keep having numbers here too. As you keep going, you keep having numbers here too. But I think still you can make the XOR may not work, but still there is a process that always matches them with their complements. Maybe it's not matching with their complements. See. Now my logic, now my clarity is helping. Maybe it's not matching with their complements, but maybe it's using all ones existing. Maybe it's using all ones existing. See that? Do you guys see that how I got a possible solution for for D2? I don't want I for D2 maybe it's not complement. Maybe it's not complement. Maybe this is fine enough. 1 0 1 1 0 1 0 0 0 sorry 0 0 0 1 0 0. Maybe this is also fine pairing. Why? No one is getting wasted, right? No one is getting wasted. Do you see the difference of clearly proving things? And 1 minute, I'm getting a call. Yeah, hi, bro. Yeah, that is type racer. The other one is monkey type. Type both. Try both. Type racer. Racer. Yeah, but try monkey type also, bro. Monkey type is better. I mean, monkey type is easier to begin with. Okay. I am busy, bro. I'm doing stream, I guess. Right? Bye. guys, maybe, do you guys see that? Do you guys see? You have to see, even I got that, but see, even D1, some might have solved by random complement idea. Without seeing that, we are using every possible bit from both AI comma BI. We are using every possible bit. See, do you guys see that difference? Pradeep, you have told me that I can solve it instantly, probably, right? But because I guess I get random ideas quickly from somewhere, but that's not how I do. I do things, I can say what I can say, and then I will think of a simple proof. Again, when I write, it's not like some positive bullshit that you see on LinkedIn, okay? That I use them everywhere. Do you guys see that? When you do bitwise OR, that's definitely an upper bound. Using every single one is an upper bound. But now you can match some zero with some zero too. Maybe you cannot match everything perfectly, but maybe you can match in such a way that all ones will differ. Maybe that's possible. I don't know. If that's not possible, we have to solve some other problem. But then I'm assuming because D1 is getting solved with that logic, so maybe D2 also will get solved with that logic. Maybe, or maybe guessing is enough because it had so many solves, right? I don't know why am I complexing this problem because it has so many solves, right? 1275 means it's an easy one. So this is done. See, I think because here also, if there were like many zeros, if there were many zeros, I would have skipped all of those zeros, I guess, right? Okay, here also we are skipping zeros, but then we are matching those zeros with ones. I don't get it. And I don't care. But then one thing is clear: whatever the max significant bit is, we are making them as ones. Okay. If L equals to zero, what would we do? I don't know what did I get the solution as. This one I will flip them, and then using this and this I can pair all of them. So all the zeros are also will get paid, and then from this one, all the ones will get paid again, right? So whenever there is one here, all of them will get paid. And then whenever there is one here, all of them will get paid. So everything less than or equals to this will be, everything less than or equals to this will be 1 1 1 1 1. Everything less than or equals to this will be, so whatever is the bit, whatever is the bit, and everything less than or equals to this will be 1 1 1 1 1. So it's not dependent on bit of this, but it depends on bit of the next one, right? So it depends on bit of R, okay? It depends on bits of R's. Who told I will solve this quicker? I'm not able to solve it. My eyes are hurting. I have to sleep now. Not sleeping properly at all. So guys, help me now. Not getting you. So we can match from zero. We can match those things up to so on. Oh, I can see this one. I will just implement this one. I'm not able to get the solution people are telling me, but then I can just see that I have to do this thing. I have to take the first bit and then I have to make all of them as ones. And then I have to go to the next bit and then I have to make all of them as ones. From here, from here to the remaining, I will try to make them as all of them as ones. That's what I get. Okay, I'll just do that. I'll just do what I got. Okay, I'll just do what I got. I don't know this. Guys, I'm really not able to get the solution that someone else has told me. Okay, I'm just going with this one. I'm just going with this one that whatever this j is, okay, in next star equals to nr. Next star equals to r xor 1 power j. Okay, we are removing the max bit and then that will be the next star. From r to next star, while r greater than nr, okay, a of r equals to 1 power j plus 1 minus 1, me 1 ll. So this is what I thought. This is what I thought initially, okay? Or minus minus. I'll name it nx. Can anyone help me, please? But then, so what is happening here? I just output x. So I'm not getting something. I'm not getting something. How is this happening? When this one is there, I can take this thing. I can take these above things whenever I can make all of them as these complements, right? And then what are left? What are left with? But then I'm pairing this with these complements. But then as I go down, these things are already paired, right? So I'm not able to do something correctly. I'm not able to do something correctly. What about x equals to 0? I'm losing that. Guys, I'll quit it. I'll sleep. Pradeep, never say that I can do some problem quick, okay? See, my solution is complex. Somehow it's complex. Why? I'm able to find the pair of these things, right? I'm able to find the pair of these things. So, in the same way, those will get paid here, right? So, all the compliments of these also got paid, okay? All the compliments of those got paid. Means, what does that mean? All the compliments of this has also got paid. Guys, I will leave this. It's not working out, right? See, I thought of something, but then it's not that easy to understand this thing, right? I was able to see that, okay, we can pair this and this as complements. I know that. We can pair all the smaller things and all these bigger things as complement. We know that. So let's just do that pairing, okay? Once we do that pairing, we have everything paired up perfectly. And then now what do we have? We have few things that are left. We have few things that are left, which are one and then this thing, one and then this thing. Okay, these things are left, right? Because these things are left, What I was doing now to these things, I'm replacing this with the zeros. Okay, I'm replacing these with the zeros. So now we have zeros. So now we have zeros. And now we have these things. And now I have to pair them again. With what? With what should I pair them? How to pair them with things that have one here? That's the issue. How to pair them with things that have one here? Okay. Are they getting paired with perfectly? Okay, 1 minute. Is this symmetrical? So this thing is getting paired with what? 2 power max bit of that minus 1. But then, what about the smaller thing? With what will it get paired? It seems like it will get paired with something that has 1 here, right? It will get paired with something that has 1 here. If it is getting paired with something that has 1 here, then that 1 will remain. And then what happens? What am I doing? I mean, it's not that easy to think of what I am thinking, right? So, what am I thinking? See, whenever we have this 1, I will, let's say, pair these things with these complements, and then I will add 1 to there. Okay, now what are all left? Now these small things are left. Okay, now these values are left. And for those values, you must have 1 here. So what is my idea? I have few. I have. I can make everything complement of this and this, right? Now I have some values here and some values here for complement of each other. But just think, if these values are more, if these values are more, then they merge. So for every number that has this one, we are able to keep it with their complement, right? So let's just assume that let me just assume that thing. If I is having max bit, I will just make it their complement. Let's just assume that maybe. Okay. If I has max bit that, I can just make it its complement. Let me just assume that somehow. Okay. I won't think much, guys. I'll just make it like that because you guys gave me enough hints. I'll just do it like that now. But then I equals to 0 will be left out. Maybe it's fine. I don't see I equals to 0 fine because 1 should get merged with 0, right? Is 0's max bit 1? Let me just keep it 1. I don't get it why, I don't get it how, but then let me just keep it 1. This is not how we should be solving. I know that. What can I do? I know clearly 0 things are also getting more, right? Let's just say, guys, how is it easy? Guys, I'm ending it. Bye. Start from or equals to 0. I get that. We have to start from or equals to 0. Or equals to maximum. Why? I'm trying to pair it with this one, right? It's complement. So let me do that, okay? I'm thinking something else too. Like, shouldn't we match same number with same number if it is perfectly symmetrical? But then I don't get it. Like, if n is odd, we cannot match perfectly symmetrical, right? Then how do we do? Some bits will be lost, right? Maybe I was wrong with whatever I thought. I thought we can always do them perfectly symmetrical, right? But then maybe it's not. Maybe we cannot do that. My assumption is that all these things can be paired with their 1 plus things. And then not just all these things, but from here, from here, you can pair 2 power j minus 1. Okay, if j is the max bit, then pair 2 power j minus 1 things to these many bits. Okay, what I can see. So if I implementing my idea itself, 2 power j minus 1 things, I can pair them like that, right? I can pair from here 2 power j minus 1 things for int k equals to 0, k less than 2 power j, k minus minus, k plus plus. All of these things I can make them as I. We have I. I can be made as a of I equals to int total equals to 1 power of j plus 1 minus 1. Let's say this is what is my idea, right? Tot XOR equals to tot XOR of I. Let's say that. And a of tot XOR of I equals to, what the fuck is this? I. And paid of I equals to 1, paid of tot XOR I equals to 1, I minus minus. Would this work? So it's not being that simple. I don't know. I'm not able to solve. I power j plus 1 minus I minus 1 should be paired with I. Is that it? Can we always have them though? Can we always have them? And you have to do this from, and then you have to do, I mean, this is not perfect. Whatever you have told me, like if you come from this side, j will differ. If you come from that smaller I, j will differ, right? What is j for bigger one? Oh, really? Is it about unset bits? But how do you know which is bigger one and which is smaller one? Like, what is the final thing? Like, how many we have? Some ones, we have some ones, we have some ones, we have some ones, and ones will be keep on increasing. Guys, I'll sleep, guys. I was saying, I can see that we have to pair them to their complements, right? We have to pair them to their complements, but how do we do it? Let me try some water at least. I may be missing something because I got something complex. I'll once charge my laptop, I guess at least. Have to use all ones. What I got here was looking complex. What I got here was you can pair all of these things with their complement, right? And then I can subtract all these things, and then what is happening, and then what's happening. So I was just pairing. I was pairing two power n things. I was pairing two power n minus one things. Okay, I was pairing two power n minus one things. I'm pairing all of these things. Okay, whenever there is, I'm pairing all of these things with all of these things. Okay, what am I doing here? See, my idea was clear, right? What was my idea? You can pair all these things with their complements, right? Okay, we have all these things got paired with all their complements. Now what do I have? Instead of keeping zero things here, I will keep the one things for the top few things. Okay, for the top few things, I will keep the one things. Okay, whatever this number was. If it was all one ones, I will keep that for every one ones. Okay. I think I'm not able to see the pairing easily because we have so many things, right? For this thing, if you pair this, we have to pair for the small thing, we have to pair some bigger things, right? That doesn't seem that small. That doesn't seem that direct. See, for 1100, I may have to pair with. Okay, can I always say we pair something with the smaller thing, right? I think few things are less than half. If you are pairing with complements, few things are always less than half. I got that for these smaller things, instead of using them, I will use one. Okay, just for the smaller things, instead of them, I'll use one, is what I thought. But then what will be left out? All these smaller things will be left out. Now we have to pair them, right? Now we have to pair them. But then we can pair them with bigger things. That's the problem I am facing, right? I think instead of this, I will just look at what others are telling me, which is, but isn't that a complex algorithm? Lower ones getting paid automatically. Isn't that a complex algorithm, guys? So this shit is definitely not that easy somehow, but you guys were doing it. Let me try this thing. So you guys are telling me somehow this works out, right? If I just write it like that, it works out is what you guys are telling. But I don't see how it works out. You guys are just telling me don't do anything like that. It works out is what you are telling, right? And now why does odd match? Why is it not okay? Two times I can see that. So you guys are telling this shit will work, but I don't see how. Should I just submit it because you guys are telling me? But this is not easy, right? But that's not easy, right? I don't see it like how you guys tell me that. What is the idea? From bigger things, why are we coming from bigger things? Like smaller things are getting paid with bigger things sometimes. How did you guys come from here? Like, is it like just coming from this one? Here you can make everything that. But then what is happening here? If I don't do this, what happens? See, it's complicated. It's complicated, right? It's not a perfect pairing. Sometimes you have to pair something with the same thing. And what is that thing? Like when or is odd, when the length is odd, I was not able to see the pairing that well. When length is odd, you have something pairing with that. Okay, if that is pairing with that, how can it be its complement? Can length be odd? Length can be odd, right? I don't see it working. I don't see what's happening here. Have you guys submitted the same thing? No, no. What about when length is odd? Do we pair something with the same thing? Then how can it be complement? How can that be a complement if you're pairing it with the same thing? See, if it is symmetric, we have to pair something with the same thing, right? Cocaine. It's not cocaine, it's just some Vicks. So if you pair it with the same thing, how can that be a complement, right? I'm not able to see that pairing. I think in the odd case zero will get paired with zero. Let me assert that. See, this was irritating me a lot. I was not able to see the pairing. I was thinking, okay, I was getting irritated by odd thing. I was not able to see how that could have happened. Do you guys see? I was thinking, okay, I was getting a bit irritated with the odd case. Like in my mind, okay, if you're doing this pairing, what happens to the odd one thing, that one odd thing that is left? See, I mean, yeah, I got it. We need not make that. But then what's happening to me was, I was thinking that. I was trying to see the pairing, the whole thing. But then I was not able to think, okay, if you're pairing something with that, whenever odd number of things, I was not able to say how the fuck do we pair. But now I have understood that. Now I have understood that only in this case, only in this case, we get zero paid with that. But if that doesn't happen at all, then what are we doing? Then I'm pairing like this, and then I told I will try to go here, and then I will go. I think in these cases, whenever somehow in these cases, somehow in these cases, uh, I don't know. Only in this case, zero is getting paid with this. Like in odd case, okay, not just in this case, I guess. Maybe in all the odd cases, but then I think in even cases probably zero will get paid with, okay, zero will get paid with this thing, yeah, only when this happens. Otherwise what happens? Zero should, I think zero will go on paid with some other complement, maybe zero will get paid with some other smaller complement. Maybe it will get paid with some other smaller complement. Maybe it will get paid with this one, maybe it will get paid with this one. I don't know. Zero will get, maybe zero will get paid with these 111,000. Maybe they will get paid. But yeah, someone has told me, okay, let's say that okay, everything is getting paid. If of I, how I came to zero was I was trying to see, okay, if tot of I equals to I, if tot XOR I equals to I, what is tot? It should be zero, right? Probably. So not it. Sorry, if I equals to tot of I or I. Okay, yeah. So total should be zero, and they're complement of each other's, right? And they both are complements too. If I is complement of itself, this doesn't add up. This doesn't add up, right? It feels like zero should go to one. Feels like zero should go to one in the worst case, but then zero will go to zero in odd cases. See, one thing is still true. This thing is still true. This thing holds very true that we are saving all ones because everything is going to its complement, right? All the ones are going to its complement. So no ones will get matched. No ones will get matched. So now can we do div2, d2? So these things we can chop off. So now we have 1 here, we have 0 here. And then again I have to use some logic and say that, there is a way to pair everything with their complements, right? There is a way to pair everything with their complements. Okay. So let's do the same thing. Let's say we have 1 0 0 something something 0, and then we have some other bone 0 something 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 0. Okay. What can I do? I think probably we can still pair everything with their complements. Like complements means no two ones will come in the same place. We can do that. No two ones will come in the same place. Can we do this always? For this, we want number of ones to be odd. Number of ones to be odd, right? We want number of ones to be. There is a way. No, number of ones we can't say anything. There is a way, such a way that no two ones will come in the same place. Okay, that's the way we have to. That's what we have to show now. But what if L equals to R? Okay, then we cannot do that. No. If L equals to R, these things will be equal, right? So in this case, can we pair everything? When we have one here, when we have 1 0 here, in this case, can we pair everything? We have to think. So let's see these things as. Okay, let's just use D1. Let's just use D1. Let's just use D1. Okay. We have some pairing. We have, I think that's an easier logic we can try for. That works, right? Now we have something smaller. So now we have this thing smaller that we can't use. Now we have these things, we have some pairing, and then we have something smaller that we cannot use. What are they? They may get paired with something bigger ones too, okay? So that we have a pairing such a way that some smaller things are getting paired with some bigger things and so on, right? So now I have a question, let's say. So you have few things here, right? You have few things. You have few things here, you have few things here, right? So now, okay, now I think I have an idea. Try because I'm not able to see some great thing here. So I came down to here and then I thought of using them. So now some things here are getting paired with some things here, right? So now let's say we consider another pairing of pairing these things. Okay, we have a pairing of pairing these things now. Okay, so we have a pairing where this x, maybe that same x will be paired with this thing. So now we know this x and this x are not having any common ones, right? They both are complements of each other. Complements means, can I try to just take that x here and then, can I do that? I'm just thinking. Maybe not. Maybe this is a complex idea for D2. This idea seems much more difficult, right? Try to uh, pair these things and then use that pairing to form the above pairing. That seems a nice idea, but maybe D2 doesn't expect that much of logic, right? Probably it doesn't expect that much of logic. Here I got some jaw pain. So guys, should I go for? I think there is a way where all ones and all zeros will be saved. There is probably a way. Okay. So whenever this is 1, this should be 0. Right? For all the values, this is 1, this should be 0. Now remove that. Let's just say there is a pairing from here to here. Okay. Let's just say there is a pairing from here to here. Okay, let's just say there is a pairing from here to here, such a way that all ones can be saved. Now what would I do? Among these things, whenever these things are there, but we can't guarantee that these things will come in here, right? I was trying to keep these above things here somehow, but then this may not be occurring here at all, right? When we try to pair these two, this may never occur in between them at all. Would all these smaller things be pairing here, pairing to things on this side? Would that, is that true? All the smaller things will be pairing to this side. Is that true? Why? We have this less than half, right? This 0 means probably it's less than half. So can I say that all these things will be mapped to this side? But then we have 0 comma 0 mapping here itself, right? But then all these things, if they are mapping this side, so all the things that, no, some will be among themselves, some will be from here to here, then what can we do? So you can pair things such a way that no ones will come together, is the question. There is a way to pair these things such a way that no ones will be together. No ones will be together. There is a way, it seems. Okay. There is a way to pair such a way that no ones will be together. That's the only condition. It's not complement, but it's no ones. See, Ari, 8 is this, right? First, you have to remove the common things, okay? Ari, we have to remove the common things. When this is 1 and this is 0, then you can save everything. We have to logically use that this is 0, this is 1, then we can save everything. Okay, this is 1, this is 0, then we can save everything is what we have to use. So we can save all ones. Do you got that? So we have to think, is there a way to save all ones? Is there a way to save all ones? When this is 1, this is 0, we have to apply that logic. That's why I went to 1, 1, 1, 1, 1, because I want to apply this is 1. So I tried of saying this one because I thought of applying this being 1. If that being 1, we have all of these things are possible. See, here we have so many things being possible, right? Because so many things are possible, because so many things are possible, okay, from here, let's just take from here 2 plus 1 things. From here, take whatever this 2 power or is. Okay, we can always find their complement in this thing. We can always find their complement in this thing. but then that may not be a good pairing, right? Can I just think of pairing 00101 0010111, right? Can I think of pairing this prefix matching and then this 0 being 1? Can I think like that? 0101 and then this is 1 because now I'm trying to brute force and then these things can be anything, right? I mean, I can split everything greater than L as this is a common idea. The idea I tried here was a bit difficult idea, right? But this is a common idea, right? Okay, if I fix prefix of L, how to pair these things? With what can we pair these things, right? Is what it comes. You have to pair these things with some things, right? So what can we do? For these things, we need, can we get complement? Or for these things, can we get complement? They can be anything, right? So that's a group. There can be anything kind of. That's a big group, right? Guys, let's sleep, guys. Let's not do this. There is no low bite, bro. This is not low bite. That's not a low bite. That's just vaccination. I have some marks here, but I don't have any low bites. Guys, let me solve B. S1 is to optosone where each element in the sets is an integer between 1 and m. You want to choose some of the bits such that every integer between 1 and m included in at least one of the chosen sets. Fuck, what is this? You have to determine whether there exists at least 3 ways to choose the set. Even this is difficult, right? This can be an 3000 problem and we would never know. We can never say if this is how easy it is without trying, right? Take everything. Take everything. Some Linkin Park song is there like that. From the inside. What is that? Am I right? You want to choose some of the sets such that included in at least people will dislike my videos. I should stop such shit. So where are we? Is there three different ways? Choose everything is one way, right? Choose everything is one way. Okay, choose everything is one way. Now, can you miss one thing? Can you miss one thing? Remove one set and then it's gone. Let's think about that. Remove one set and then it's gone. Means if some value is present in this, let's think of that thing. If some value, okay, all can be taken. If some value is present only in this, then you can't remove that. Right? So now you need two sets at least that has values Okay, not two sets. Okay, leave that. So let's say this happens for, okay, if we have two sets such that removing them individually is fine. Okay, let's say you have one set, you can remove that and then it's fine. Use remaining things, right? And then you have, let's say, one more set, then we are done. Then s, what if there is only one set? Okay, what in this case, if some value is present only in this, means if you remove this, some value is disappearing. Okay, if you remove that, some value is disappearing. It means 1 to m or disjointly split among these things, right? 1 to m or disjointly split among these things. I think if you have one set, you will have another set too. You will have another set too. Am I right? What does this mean? If you remove this set, still all of these are present elsewhere, right? Okay, all of these are present elsewhere. No, I cannot say this. Because everything else can have some unique thing, right? Everything else can have some unique thing, but then if you remove that, it's fine. What I thought was, whatever this elements that are in this set, take that element somewhere else, because if you remove it, still fine, right? And then try to remove that, but then that may have some other unique thing, right? How do they come up with these problems? See, good problems, right? And my mistake, if they make B difficult, everyone will give downward. Can ChatGPT solve this problem? No. Yeah, I have to log out my account, right? So, what AI should I use? Gemini. I never logged into Gemini. Let's take AI help, guys. You guys should learn to use AI help. I don't know who to trust. We're breaking down the problem, bit mask and made in the middle. Damn, it's making it more scary. The most efficient way to handle a large number of sets n is to meet in the middle. Split the sets into two halves. Yeah, AI is taking over the world, guys. It's splitting bullshit, whatever bullshit it knows. So now we have to think. Okay, let's think about this case. Everything has something unique. If you remove that, it's gone. In this case, it's no. Because even if you miss something, it's gone, right? But then for every other set, okay, what does this mean? Done, guys, we are done. If there's only one set, no. If there are two sets, done. I mean, removing this to be fine. Why? If you removing this is not fine, what does that mean? Removing that does not fine means there is something that is present only in this. Means you can never remove that. You can never remove such a thing, right? So it's all about just that. You can never remove that because it has something that is not there outside. So you can never remove that. So it's a simple and easy problem. Done. Whenever there are two removable sets, yes, So some sets are removable, some sets are never removable. But if this is removable independently and this is removable independently, we cannot say removing them together is good. But remove this, keep everything. That's definitely good. Okay, it's all about removing one set at a time. Number of sets you can remove one set at a time. If there are two sets, you can remove one set at a time. You can take that. If there is only one set, you can remove one time at a time because you cannot remove anything else. You can only form two things. You cannot form three things. So simple and easy problem. What is a bad thing? If you can't remove it, it's bad. Okay, if you can't remove it, it's bad. And what does it mean if you can't remove it? So in total, its frequency should be 1. I don't know who to trust. No surprise. On the total frequency, so I have to maintain arrays int a of n, vector int a of n, I equals to 0, I less than n, I plus plus, int l, scene l, l is the size, right? For int j equals to 0, j less than l, j plus plus, int x, scene x, a of I dot push back of x, frequency of x plus plus. Okay, now int bad means something you cannot remove. Okay, if frequency of x equals to 1, then okay equals to 0. Why? Then you cannot remove that. You cannot remove that, right? Good, let's take good. Good plus equals to okay. If you can remove that, it's good. So if frequency 1 means not frequency 1, but frequency of that in this array, right? What will I do? For each x, I will make frequency of x minus minus. And then for each x, I will check if frequency of x 0, I will make okay of 0. And then what will I do? I will update the frequency again. If good is 1, you can only remove this thing and you can only form at max 2 subsequences. You cannot form 3. That's where significance of 3 coming from. Okay. Ah. So it's simple, guys. We clearly solved this problem. So let me see difficult C. If I can solve it, we are given an integer n of binary string s of length, and for permutation of length and an integer x, we define find of x as the following pseudocode. I cannot do this. let m be a random integer between L and R inclusive if P of m equals to, okay, random integer. While x less than or we choose something random. If P of m equals to x, we return m. If P of m greater than x, is it a sorted one? Or equals to m minus 1, if else, okay, probably it's a sorted one. We randomly choose, random is as good as half, I guess, right? Random is almost good as half, somehow. But I'm not sure. Not as good as, at least little bit good as. So an x is stable if and only if find of x is always not defined and p of x is always holds no matter how the value m is selected in the process of the pseudocode. Okay, what does binary string do now? What does permutation do now? Oh, it's a permutation. It's a permutation. It's not a sorted array. Okay. You have to construct a permutation of length n such that for each I is stable or determine no such permutation exists. So whatever the m is chosen, it should never go to undefined, it seems. That seems very restrictive, right? That seems very restrictive, right? In the beginning itself, let's say, it means everything should point towards it, right? That somehow means everything should point towards it, right? Right, guys? Because we are chopping off. We are chopping off. If we find something bigger, it should point towards wherever x is. Whatever the random value you choose, it should point towards wherever x is, right? Because we're chopping it off. If it points like x may be this side, we are fucked. In the beginning, in the first step itself, we are fucked. Let's say x was here, and then some bigger thing points like this, we are fucked. So what should happen? So this is being direct. It's like if x is stable, whatever the random m was chosen, that should point towards x. That should point towards x means that should be, if it is on this side, that should be greater. If this is on this side, if it is lesser, it should be on this side. Okay. So all these elements should be greater than this, all these elements should be less than this. Then what happens? Whenever you are here, you point. So that thing will split this thing. In permutation, it will split this thing perfectly. Then x is stable. I mean, if I draw them like a graph, all these things are bigger, all these things are smaller. Then whenever you are here, it's smaller, so it says to go here. Whenever you are here, it says to come here because smaller thing is here. So if this happens, x is stable. So implies and implies when x is stable, this must happen, and if this happens, x is stable. So it's implies and implies done. So now we know what stability means. If and only if. So we know. So first we have to very clearly solve what it means to be stable. It means to be stable means, okay, everything greater should be on this side. Everything lesser should be on this side. Means p of x equals to x. Is it? Is it p of x equals to x? Only then it's stable, right? Everything greater should be on this side. Everything lesser should be on this side. Means p of x equals to x. Only then it is stable. So this is an observation. If you don't make this observation and then if you think, you cannot get anywhere. P of x equals to x is a necessary condition, and then you have one more. And then you cannot have this here too. P of x equals to x. Everything less than x should be less than or equals to x. Everything greater than x should be greater than or equals to x. And so on. So now, for all ones, if you make p of x equals to x, okay, let's say we made for all ones p of x equals to x. So now, it should be true that all these things are stable. All these things are stable. Okay, it should be true that all these things are stable. Okay, it should be true that all these things are stable, but In between, none of them are stable. In between, none of them are stable. Okay. Do I even have viewers or am I talking to myself? It's not about making that graph, it's about seeing it a bit. Why did I get minus delta? Yeah, I was just trying to explain, right? That's why. I was just trying to explain, right? It's an easy thing. Like everything here, this side should be greater, everything this side should be lesser. I don't think this helps. I don't think this helps. It's just sorting, right? Everything before this should be greater. Everything less than this should be smaller. Means this is at x. So it's we know we need not make this graph, but then I'm just doing for no reason. So now that have happened for some things, okay? If that have happened for something, some excess, that means you have to have elements here disordered. 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 If you can make these things in disorder, you're done, right? If you can just make if the size is greater than one, you can make sure that they will be in not order. But if the size is one, if this is satisfying everything, this will also satisfy one, then it's impossible. We need not even think more on these things. We can just make them not equals to one. So it's done. If 101 exists, it's impossible. Why? It's impossible. You can just take it will hold for this too. If it's holding for this, it holds for this. So guys, 101 impossible. Else we can just cycle them. Cycle in between things. Done. So C is not that difficult problem. It's about finding some necessary and sufficient conditions which are quite common. Right. So guys, I will end it. D2 is difficult. Adjust with my E. Even if 10 is there, that's also wrong. 10 is also wrong. I'll add an initial one and a final one, okay? I don't know if this is the best way, but then that doesn't hurt, right? Let's assume that there is a 0, 1 here and there, 1 here. The problem inside still remains the same problem, right? But then it hurts me a bit. Let me just handle that. All the 0 components should be less than or equals to 1. That seems good, right? I have to say tomorrow that I'm going to quit Apple. Like, not quit, I'm trying to resign, is what I have to say tomorrow. I don't know how I can say that. Not even sleeping. We have to fill from I to j, right? I have to fill from I to j, which is nothing but in one based index I plus 1 to j plus 1. So what would I fill at an I plus 1? I will fill the next thing, right? For int k equals to I plus 1, k less than j. So j plus 1 is the bound. J is something you have here. And then you have to less than j, k plus plus. P of k equals to k plus 1, let's say. And then P of j will be equals to I plus 1. So guys, it's about finding necessary and sufficient conditions. I tell you people, it's always about finding necessary and sufficient conditions, but then you guys will not believe me. You guys will ask for topics. I don't understand why you guys do that at all. But it's about finding necessary and sufficient conditions. And I will just check once if I'm doing what I want to do in a right way. 0, 1, 2, 3, 4, right? How is that getting happened? That's not seeming to be right, right? We have 12. This is not right. How is this not right? Okay, this is correct. Then what about this 12? Oh, it was no. What about this 11? Ah, that seems to be correct. I do whatever it takes. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. This is was our. I know I should not do this, but light, guys. It's night. It's night. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It says we are doing wrong for this. It should be no. It should be no, right? It was min 0. It was not max 0. What we needed was mean zero. I don't know why I did that mistake. I'm sorry. I can't think probably. I'm exhausted. So I'll sleep. Let me do A and then I'll sleep. We call an array balanced different only if the number of occurrences of any of its elements are same. For example, 113366 are balanced, but 13333. You know that empty arrays are always balanced. You are given a non-decreasing array A consisting of n edges. Fix value. Any small, right? Fix occurrences. Then you can take for each different things, you can take that much, right? So brute force number of occurrences. Okay, frequency. Let's say I have frequency. Okay, number of occurrences. Let's say C be the number of occurrences. You're taking one thing, you're taking two things, you're taking three things, up to so on. You can take at max n things, right? You're taking these many things from each of that. Okay, now so we're maintaining frequencies, right? Now we have frequencies. If I am taking, can I take C things from one? Int values equals to 1 less than or equals to v less than or equals to n v plus plus. Can I take 1? If and only if f of v greater than or equals to c, we can take 1. And now we'll take c things, right? Or I can just take this one. I can take this one. And we can take 1. We can take v. So now that we know all v's we can take, answer equals to max of answer comma c times pos, right? So this is a good problem for A because it's not so small, but it's like two loops, and still it's small logic. Maybe it's a good one. I cannot try F. I cannot try D2. I'm leaving. I'm sleeping. Guys, bye. No, bro. I'm working in Apple. Who the fuck is telling 80 LPA bass? Bass. It's not 80 LPA, bro. It's not 80 LPA. It's not 80 LPA. I'm not that good of a coder, right? It's not 80, bro. It's not 80. Don't spread fake things. It's leave. Let's no. I don't know if I have to leave or not. But then I have to try to tell it too. I have to try. I think I got some small startup offer. It's not any big startup, but still I'm thinking maybe I can learn more at startup. Yes, do binary search on that now, bro. It's less, bro. It's less. It's not high. I am thinking I can learn more at a startup than at Apple, right? Because growth won't be there. I cannot learn more. It's low. You guys making shit up. It's low. I don't know. Does quant pay a lot more? Should I go for quant? I think quant pays more money for sure, right? I'm saying Insta. I still don't know, bro, if I should choose quant or not. I still don't know. I'm applying for some quant companies too. But then I don't know if quant work is really good or not. It is good, I guess. I would be interested if it is challenging, right? But then I don't understand it. Yeah, but is it really good? I don't know. Yeah, quant, they said like it's very high. But then I'm going for some small startup. That's it. I'm trying. I think I asked my friends for referral, but then I don't know. They're not. The guy is not. I'll ask him once again at at Graviton maybe. They're paying slightly more, bro. The startup is paying slightly more, not too much, a bit more. Yeah, I want to learn too. I want to learn too. All are same. You have coach. All are same. Guys, how to download this and upload on my channel? I want this thing. I've shown this many times before too. I want this thing on my channel. Can I download that? ICPC Live IITM. And then I went to D. I thought I solved it, but then I wasted my 4 hours on that because I missed it. I got solution in next 10 minutes. I got solution of D in next 10 minutes, but then I wanted to do first solve or second solve on that, and then I fucked up. I fucked up entirely. The whole contest got fucked up. It's should have been a bit careful. People who solved we haven't solved D finally too. Can I upload that? Is that plagiarism? Is that plagiarism, guys? Before quitting, make a video of Dale in life. But mine is not rubric. Rubric, I had rubric offer in my intern, but I don't know why I didn't choose it at that time. But now I'm just going to some startup. It's just hair different hair. That's it. It was just 1 year ago. 1 year and few months. Companies are weird, guys. We may not get offers that easily. Did you try for Google? In office I didn't get, bro. But I see some of my friends who are working at Google are going for smaller HFTs too. One guy went for smaller HFTs because he want to learn more. Not smaller, like medium HFT, I guess. That may not pay too much, but then they pay good. Guys, my startup is paying decent, not high, but my Apple salary is 34 or 36, right? 38, let's 36 or something. I'm reducing it, but okay, 36 or something, right? But then base is 20, stocks are 12. So instead of that, if I increase base, that would be good, now. Yeah, even I am thinking mid frequencies. Even I am thinking mid HFTs. Yeah, slightly good pay and growth. I'm not trying for the best pay, okay? My Apple base is 20. My Apple base is 20. Stocks are more. Stocks are like, sorry, 20 or 22. Apple base is like 20 or 22. Uh, stocks are 12 lakhs. Joining bonus is 2 lakhs. Some relocation things are there, so it's around 36 or 37. That's it. It's around 36 or 37 total CDC. Maybe there are some other benefits, but then that's it. This is some big nail that came off. Guys, I'm sleeping. Probably, right. And I don't get to do good things too. I think I don't get to do very complex or like not even complex, like even writing a bit complex code too. Bye guys. I'm sleeping. Yeah, bro, if you even become 1400, you can say you're good for coding, really. Guys, if you people are like at above specialists, like around 14 to 15, sell yourself well, okay? Don't think that there are other people, because 14 to 1500 is 1500 is enough for doing any coding job, I guess. Most of the coding jobs, if not HFTs or like very high demanding ones. For startups, maybe some startups may seek even good people. Then it's a bit difficult, but expert, if you're expert, I think try to sell yourself for some startup, for some company like Google or Apple or some other thing. Okay, why am I not going to HFTs? The company that I'm going to right now, the startup company I'm going to it because it's also remote. So I'm not sure if I'm going. Tomorrow I have to tell to my manager that I am considering shifting. I don't know if telling like this publicly is good or not too. Compul code. What are compul codes, bro? I'm just joking. It's complex code. Guys, do you want to play Smash cards with me? No, I'm just joking. You need not play Smash cards. You guys can drop if you want. I got only that, and then I chose that. It's not magic. My eyes are hurting. Do you guys want to know my skincare and hair care? What about muscles? I don't have much right now. So the secret to muscles is I don't have much, but still, if you have, I will win. People who want to play, just watch. But then, but then, but then, see, bro, Pradeep, if you are good at CP, you have to take things challenging. Okay, you have to take things challenging, and then I wish I can see the chat. Okay, so that I can talk while playing. Right. It's being not possible. Just watch me play. Watch me win. I don't play. Is my FPS right? Is my FPS correct? Guys, Can you guys see me clearly? Sorry for this game. I know I should not do games and all. But let me win one game. It won't be that boring, I guess. Fuck. We have 6 people. Damn. 7 people. It's difficult in the beginning, but don't play these games. Don't learn bad habits from me, because I things work out for me. But if they are not working out for you guys, learn some good habits from me too. Okay, good habits means like I try hard, like a bit. I try hard on solving. I don't tell lies to myself. I do many such things. Okay, I do many such things. So you guys also should try hard. Try equally hard at least. So I'm losing. I won't. 20 right. Guys, root for me. We are winning this. Fuck. I'll win. Just root for me. I'm a pro. When I said I'm a pro, I know that. Fuck. So do we have viewers? I think just keeping it here is better. I'm 2024 pass out. I'm like a old guy. I am 32 years old. I think this game's a bit boring. Right, winning is a bit boring. I need challenging opponents, but I'm not 32, I'm 22. I'll turn 23. Still old. You guys are probably kids. I missed him. Don't get addicted to these games, guys. Is it clear? I know it's not a better game. I know it's not a better game, but then we used to play this in college. That's why I like it. That's the only reason why I like it. It's not like that. I mean, we used to play it in college. That's the only way. That's the only reason I play it. I don't play it. I don't play it often because it's streaming. I'm trying to become a better streamer because you guys seem to be not interested in code forces or coding problems, right? That's the only reason. Some other games I don't play, bro. I don't waste my time. CP is the only thing I do. You can get addicted to this really. If it is if it is few people, it becomes tough. So can Lily get 4 kills before I get Lily get 4 kills before I get one? I don't think so because I got one. No, no, no. Where is Lily? I will kill Lily. Where is that guy? Oh, he's here. Haha. Guys, done. Work culture at Apple. I've heard that in Microsoft and Google it's a bit less. I don't know about Google. I've heard that in Microsoft or somewhere else it's less. Here there is work. Here there is work in the sense. Okay, maybe I'll open that again. People want to play. I don't know. I just moved away. Okay. Uh, so we cannot make these things, guys. Some people will come up and say you wasted my time, right? Some may come up and say you wasted my time. I think if I can see the chart, I can answer your ask me anything questions. Yeah, I think it's done. We cannot play one more game. Yeah, it's done. I'm not pro at gaming. Only this game. Only this game. So guys, we can end the stream, I guess. Bye. Good night. Yeah, ICPC tips. See, go to gym, make you a team. Don't believe that the contest problems difficult. Okay. Dominator is making a round in 3 days. Satyam is making a round. Can these two people leak me questions, please? I have to gain my rating back, guys. Not due to. I solved this very quickly, but then what happened to this? I don't know. How is this easy? I can still see. How is it easy? It's complex, right? You have to think that you can somehow save all once. And something here must go to something smaller, right? Otherwise, you cannot save these all once. You have some number of max bit ones, and then you have to match them with. It's not that easy. How do you prove? If you are trying to go like this, how do you prove that the other thing will comes? See, I got a remote startup offer. Yeah, he's the same guy. I have his number too. I know you also have. So guys, I'm ending the stream. Guys, at least today I'll try to sleep early. Bye. For ICBC, give gym contests as a team. Think what better you guys can do as a better. Think, analyze each question. Okay, if we have not discussed, could we have done this better? How difficult is this solution? Try to analyze things. Even on CP, give a contest. Try to analyze exactly why something went wrong. What you could have done better to do something well. You have to analyze. You have to think a lot on how you can improve. Maybe try to characterize problems into, okay, this problem is okay. Try to prove things clearly. More, don't get scared in problems. Those are the things for ICPC.